Alright, so now actually calculating some of these one-sided limits. So as I have stated there at the top, use direct substitution when possible. Same thing I told you at the beginning of section 1.3 when we started direct substitution. I said always try that first, and if everything works out and you get an answer, then that's great. You're ready for the next problem. So same thing is true here. You can still do these by direct substitution. But it says if this indeterminate form, again, of 0 over 0 occurs, then, of course, you've got to use, as I said here, the necessary tricks, like the factoring, the rationalizing, any of that we used in the previous section when we had an indeterminate form would still apply here. Okay, so the first one, what you would... if you try your direct substitution, then you're going to get the 0 over 0 for that indeterminate form, okay? So, like the necessary tricks that you could use here would be some factoring. Of course, in your denominator, you have a difference of squares, so x plus 2 times x minus 2. Now, you've got x minus 2 in the bottom. Here you have 2 minus x, so you'll need to take out a negative in order to be able to turn that around. So then, your x minus 2's will cancel out. So I have 1 divided by x plus 2. Okay, so it appears that there's nothing else to do, so let's try the direct substitution now and see what happens. So if you directly substitute 2, of course 2 plus 2 is going to give you 4, so negative 1/4 would be your limit. Alright, this next example is actually bringing the rationalizing the numerator back in here. So we have the limit as x approaches 4 from the left. If you were to do the direct substitution, of course, if you put a 4 here, square root of 4 is 2, so 2 minus 2 is 0, 4 minus 4, so again, this one's that situation of that indeterminate form. Now, since you have the radical in the numerator, this is going to be where you're going to rationalize the numerator. So that means I have to multiply top and bottom by the conjugate of this. Alright, so in my numerator, I'm going to have to use my FOIL method. So square root x times square root x is x. Square root x times 2. Negative 2 times square root x. Negative 2 times positive 2 gives me negative 4. And again, don't bother multiplying out the bottom because there's going to be some canceling that you'll be able to do there. Okay, so these are going to add out, so that will leave me x minus 4 on the top, and then I've got my denominator. So now the x minus 4's will cancel. So that would leave me with just an understood positive 1 on the top, square root x plus 2. So now if I were to do the direct substitution, that'll end up giving me 1/4. So you'll still have some practice of those indeterminate forms even with this section. Okay, next one. Okay, so limit as x approaches 2 from the right of the absolute value of x minus 2 over x minus 2. Now we haven't, I don't think, worked one with the absolute value yet, so this one will be a little bit different. Again, this would be the indeterminate form. If you substitute it in your 2, then you are going to end up with 0 over 0. Now, here's how you handle your absolute value. Okay. What you've got to remember is with your absolute value, like if you're solving an absolute value equation, remember you always set it equal to positive and set it equal to the negative. So you've got the same concept here that you've got to consider and apply. So like if you're coming in from, let me come back up here and write this note. If you're coming in from the right side, then that's going to be the positive of the x minus 2, whatever this expression is that you have in here. Of course, the positive of this is just that, okay? But if you're coming in from the left side, then it has to be the negative. Oop, I didn't mean to write that. Then it would be just the negative of whatever you have in here. Of course, that would end up, well, you would actually want to just leave it that way. Don't bother distributing the negative. But this problem, I'm coming in from the right-hand side. So since I'm coming in from the right-hand side, when I go to rewrite this, then I'm just going to take, based on the right, you know, taking the positive of this, it doesn't change. So what'll happen is those cancel each other out, which means you just haven't understood 1, and the limit of a constant is just the constant. Okay? Now, if this had been from the left, let's just write this down here. Now, this is not this problem, but let's say that this changed to be from the left. Then you would have to take the negative of the x minus 2. Okay, so your x minus 2's are still going to cancel, but see, in this case, you're left with a negative 1. But again, the limit of a constant is just the constant. So in that case, your answer would be negative 1.